Okay, let's unpack this. We're diving into a challenge today that is, well, truly immense. Figuring out how to decarbonize every single building on the planet. Just think about the sheer scale of that.
It's massive.
Right.
And the source material we're looking at for this deep dive, it's an article focusing specifically on BIM, AI, spatial data. It really lays out one view on why this is so critical and how technology might offer a path forward, at least according to this perspective.
Right. So our mission here is to take a deep dive into this particular source. We want to pull out the key insights, the important bits it presents, and
Right.
explain its view on the urgency, the scale, and these potential tech solutions, all for you, the listener.
Okay. So right off the bat, the source grounds the challenge in a pretty stark reality.
It really does. It mentions a World Green Building Council report saying every building basically has to operate at net zero by 2050. That's the target they're citing as, crucial if we want to stay under that 2 degrees Celsius warming limit from the Paris Agreement.
And to really hit home why buildings matter so much here, the source notes the sector accounts for, get this, 30% of global energy-related emissions. Just to put that in perspective, that's roughly the same as the total emissions from, say, China.
Wow. And here's the reality check the source gives us. Compare that 2050 goal with where we are now. Globally, there are only about 500 net zero commercial properties. 500. So going from that to basically every building in less than 30 years, that really highlights the huge task ahead for decarbonizing all our buildings.
But the perspective in this source isn't all doom and gloom. It actually argues the good news is, well, we already have many of the tools we need to start tackling this.
And it specifically points to three key technologies it sees as central, right? Building information, modeling, BIM AI, and spatial data.
Exactly. Let's start with BIM and this digital visualization idea because the source gives it quite a bit of weight. It argues BIM is more than just a design tool. It actually helps create a kind of cultural shift in the industry
A cultural shift? How so?
by enabling much closer collaboration. Everyone involved, architects, engineers, contractors, suppliers, working together more tightly. This helps get that greener buy-in right from the start.
Okay. So because everyone sees the same digital model early on, they have better information. They can spot waste, maybe inefficiencies in energy use, or question poor design choices before things get built, which saves money and carbon later, I suppose.
Precisely. Those shared digital models let teams not just see the design, but simulate and analyze decisions almost in real time. It makes sure everyone's aligned, sees the same vision, and it can cut down massively on those costly errors later. You can test countless tweaks digitally first.
And that visualization part feels really key, like the source emphasizes. Seeing a design in 3D, or maybe even VR or AR, it says it's manifestly different from just looking at 2D plans. It makes it tangible, easier for everyone to understand. Right, and that helps get people invested and grasp the real-world impact of choices.
Definitely. But the article's clear. This digital stuff isn't just for the design and build phase.
You're right, it goes beyond that.
Yeah, the source talks about this digital lens revolutionizing operational efficiency too. After the building's up and running, it gives you a full view of the carbon impact of decisions. Not just the initial ones, but, continuously through the building's whole life.
So what kind of things are we talking about monitoring?
Things like real-time energy use, predicting maintenance needs before something breaks, overall sustainability metrics, and this constant stream of data. It guides everything repairs, upgrades, how the building is used.
Okay, so that covers new builds and running them, but what about the enormous number of existing buildings? They need decarbonizing too. How does digital help there?
Good question. For retrofits and refurbishments, the source highlights that this digital approach makes things like end-of-life assessments much easier for owners. You can create accurate digital models of older buildings, maybe using scans, historical data.
And the point there is to make it easier to renovate or reuse buildings instead of just knocking them down, because demolition and rebuilding is so carbon intensive.
Exactly. Encourage renovation, reuse, adaptive use.
Yeah.
It also really helps with whole life embodied carbon assessments. That's tracking the carbon footprint of the materials and construction itself from making them to putting them together, and even disposal. Doing this digitally informs better decisions.
So it helps make the case for circular thinking, especially when the pressure is on to, as the source puts it, only build if necessary. Having that solid data must build confidence with investors and stakeholders too, showing the environmental and maybe economic benefits.
And looking forward, the source points towards 2030. It sees a clear trend. More focus on intelligent, flexible, sustainable buildings an accelerated shift to visualization and automation, powered by these digital tools.
And the benefits they see from that. Faster planning and building times and making it easier to plug in green energy sources.
Which leads nicely into this concept the source calls living buildings.
Mm.
The forecast is that, not too far off, most buildings will have smart devices, beacons, embedded everywhere, constantly monitoring energy use, other factors, in real time.
Like temperature, HVAC, lighting, fire safety, predicting maintenance, seeing how many people are in a space, even checking the building's structural health.
All of that. And when you combine that real-time data with automation and visualization tools, the source sees this, creating ultra-efficient and highly responsive buildings. Buildings that optimize themselves and use way less energy and resources.
Going back to the design phase for a second, that speed aspect, the article really stresses that AI, spatial data, 3D visualization, they're all advancing together, and that's going to speed up both design and planning for maintenance quite dramatically.
Yeah, they even suggest a future, maybe not that far away, where machine learning could actually generate design proposals. Proposals optimized for energy efficiency right from the start, using complex site data and material info.
And it's not just the building fabric, is it? It's also about power. The source predicts most buildings will soon run primarily on clean, renewable energy.
Could be on-site stuff like solar panels, maybe small wind turbines, or they suggest maybe strategic investment in microgrids, local networks with renewables and battery storage, kind of like decentralized energy hubs.
And the idea isn't just isolated buildings. These on-site and off-site renewables connect into a larger smart energy system.
That's the vision, a system that optimizes producing and using clean energy across many buildings, balancing supply and demand smartly.
And for buildings generating their own power, being part of that network gives them better access to their own data, helping manage costs.
Right, better data access, better cost management. So what the source pulls together from all this tech, it's a clear argument. Climate change is urgent, needs action now, and it absolutely demands closer collaboration across the whole building sector.
And the core message seems to be that these big advances in data and our ability to analyze it, driven by this digital shift, they offer what the source calls the master key, the key to unlocking a decarbonized future for buildings. So we've taken our deep dive into this source, looked at its perspective on the massive challenge of decarbonizing buildings by 2050. We explored its view on technologies like BIM, AI, and spatial data being critical tools, and its vision for these future living buildings and smart energy systems.
Yeah, the main takeaway from this source is really that argument. Using these digital tools isn't just helpful, it's essential. Essential if we want to get the speed and efficiency needed for this huge transformation of all our buildings.
Okay, so that's the technological vision laid out in the source. But given the sheer scale of this and how much it relies on interconnected digital systems, data flowing everywhere across basically the entire global building stock, it leaves you wondering, doesn't it? What might be the biggest non-technological hurdle the world faces in actually making this incredibly complex, data-driven vision a reality for every building? Something to think about.